let's continue to the second part of our lecture. So we would like to introduce the concept of DIFU and DIFD, whereby DIFU is actually differential up instruction. The code is 0 and 3. So when you try to find the instruction inside your CX programmer, you can type DIFU, or you can also type 013, which will give you for example, I'm removing this, and then we take the block. You can type 013 and it will give you DIFU, right? So DIFU turns its output on when it detects off to on transition. Okay, what is off to on transition? So it is a rising up from 0 to 1 transition in its input signal, and DIFU and DIFD are usually used for sensor application or pulse function. So instruction will be executed only one scan when running a program. Okay, so whenever the system detects a transition from 0 to 1, it will trigger the bit for the output. Okay, so if it detects again, so this is a transition from 0 to 1, it will trigger another output. So when CIO goes from, this one is from off to on, in the following example, CIO 100, the output is turned on for 1 cycle. Okay, so this is the ladder diagram. You have an input button which is connected to an internal relay, for example IR1. So whenever you press the start button, for example this is a start button, the system will detect the transition, differential up, transition from 0 to 1, and it will turn on the output for 1 cycle. And when it detects again, it will again turn on the system for another cycle. So this cycle is turned on based on our program. So usually it will take around 1 to 5 seconds. The cycle is very fast, okay, around 1 to 5 seconds, but it also depends on the program. The lengthier the program you have, the cycle will be the duration for the cycle will be more. Okay, so this is DIFU, and this is another DIFU, differential up, which is a transition from 0 to 1. So differential down is DIFD. Okay, it turns its output on when it detects an on to off transition, on to off. So from 1 to 0 transition in its input signal, from high to low. So DIFU and DIFD, as mentioned earlier, are usually used for sensor. So this is the example of transition from high to low. So this is the DIFD, high to low. And example of application, we have a stop button, for example. Okay, never mind, we can use another start button. So this start button connected to the DIFD instruction, connected to internal relay. So whenever we detect a DIFD transition from 1 to 0, it will turn on the output for 1 cycle, and when it detects again, it will turn on the output for another cycle. Okay, how is the cycle scan? So let's try to draw the timing diagram. So we have a start button, then we have DIFU, then we have a stop button, and DIFD. Okay, when we press the start button, so this is the example of pressing the start button. We want to take note of the transition from 0 to 1. So this is DIFU. So what happens when we press, when it detects DIFU, it will turn on the output for one cycle over here, and it will remain off. Alright, so the same concept as for the stop button, which is connected to DIFD. So for example, we are pressing this button over here, and there is a transition from 1 to 0. So the transition will be here. This is the DIFD. So the output will turn on once it detected DIFD. So both of the output will be turned on in one cycle scan, which is very quick. Okay, so let's have a look at the example. So for DIFU and DIFD, the operand to be used, we can use the CIO, okay, input or output channel, work area, holding area or auxiliary area. So holding area required battery backup, because for holding memory area, okay, so when you turn off the power supply, it should hold the memory value. Okay, meanwhile for CIO and working area, so both at the memory, temporary memory location. Okay, so when you turn off the power supply, the memory will be deleted. Okay, it is called a volatile memory. Okay, so usually we use CIO or working area for our DIFU and DIFD. So this is the example where we use a start button connected to DIFU and using working area. So when you want to use working area in the memory, so you need to start it with W. Working area address will start with W 0.00 0.01. Okay, so this working area can be used like internal RAM. Okay, so when you choose the start button connected to DIFU, which will trigger W 0.00 address, which used to enable the next rung and turn on lamp 1. Okay, so you can see here, when you use DIFU, the logo or the symbol will become like this. So this is the symbol of using DIFU bit. Okay, so we can try to simulate this, and then we have another stop button connected to DIFD, and for this case we choose internal relay. We choose address of 10.00, and this one connected to lamp 2. So we would like to try and control lamp 1 connected to start button using DIFU, and controlling lamp 2 connected to stop button using DIFD. So let's have a look and implement this in CX programmer. Okay, this one is because I changed it to reset earlier. So we will open DIFU and DIFD. Okay, so this is the one being implemented in CX programmer. So you can see when you are using DIFU, the double line is on the left hand side. When you are using DIFD, the double line for the coil is on the right hand side. Okay, when you start the system, when you press set on, okay, so you can see that it is not triggered. Okay, so it's actually not it's actually triggered, but because the cycle is very fast, so that's why we cannot see or capture the output. Okay, so there's a solution to this on how we want to capture the output. Okay, we want to keep the bit of the output. So over here, whenever it triggers, it will set the bit, but because of it is being too fast, we cannot capture the bit and see it at the output. Alright, so how do we solve this problem? So let's stop this one and go back to our slide. We need to implement latching for each output. So that's how we can make the output remain on once we release the start or stop button. Okay, so the problem with the current program is that the output is very fast. Okay, the cycle is very fast. We cannot capture the change in the output. Okay, so over here we would like to observe the output, so that's why we can add a latching at both output. Okay, attached to both DIFU and DIFD bit, and this one is DIFD bit. So let's try and implement this one. Need to stop this first. So put the output in parallel. Okay, another one over here. Okay, let's try to run this. So when we start the button, we set the button, okay, you can see the output remain on because we already capture using latch. Same goes to this one. When we press on the set button, the stop button for lamp 2. Okay, so the difference is that the DIFU, it captures whenever you turn on the system. Okay, because it captures the transition from 0 to 1. But for DIFD, you need to turn it on and turn it off before it can capture the transition from high to low. So currently, the lamp is not turned on because the system is currently high. So it needs to capture the transition from high to low. So we need to set the system to be off. Okay, so only then it will capture the high to low transition and turn on lamp 2. So that's how we implement latching for each output to see or observe the output when using DIFU and DIFD. Okay, so we have done this simulation. Okay, differential up by pressing the start push button instantly will turn on lamp 1. But for differential down, you need to press the stop button. Okay, this is actually stop button because this one is stop button, and then we need to release it before it will turn on lamp 2. So how do we reset both lamp? So we need to implement a reset button for both lamp. Okay, how do we do this? So same concept like the one that we have used before, okay, in our previous lab. We can put normally close contact reset button in series with the output. So when we press the button, it will cut off the rung. So it will cut off the rung, and the lamp, both lamp will be turned off. Okay. Alright, so this one we can, I think I have the circuit, I have the ladder diagram. Okay, I haven't put the reset button. It's okay, we can put the reset button to test. So this one is 0.02. Reset. And put in another reset button. Okay. So we can test the system. So when we set on the start button, lamp 1 will turn on, and we can cut off the system by setting on at the reset button. Same goes to the DIFD. Set it on first and then set it off to trigger the high to low transition. Let's see. Okay, make sure you set off. Just now I set off this one, I set on this one, so the button is being pressed, so we need to release it first, set it off. Okay, so then we can try this. Set it on and then set off to trigger the differential down. Okay, transition from high to low, and then we can use the reset button, set it on to cut off the current. Okay, we can release it by setting it off again. So that's how you implement reset button for DIFU and DIFD ladder diagram. So let's try and modify example 1 with DIFU and DIFD instruction. Simulate and analyze. So for this example, we are implementing DIFU and DIFD together with set and reset button. So when we trigger DIFU over here, it will then trigger the set button. So we are trying to control the same motor. And then we want to use the stop button, which will trigger DIFD and triggering internal relay 1, which will then turn off the motor 3. Okay, so let's try and simulate the ladder diagram. Okay, so when we start the system, set it on. Alright, so the system will automatically set. So this is the same concept like the one that we used latching before. Okay, so over here we need to use latching in order for us to observe the output. So we need to implement latching, but when we use set, because it already are keeping the state of our input bit. So that's why it will trigger the output, and we can see the output because the input bit is being saved into the function. Alright, so when we start the system, it will set the motor, and when we press the stop button, set it on, and then because it is differential D, so remember you need to set it on and set it off before it will trigger the reset button. Alright, so we can use this to set the motor on. Once the motor is turned on, we can stop it using the reset button. So currently the motor is on, so we set this on and set this off, and the motor will be reset. Alright, so this is another application if we want to use multiple conditions. So we can use them in the same rung to create pulse function. This is the example. For example, you have sensor 3 at the input of 0.04, and then you have sensor 4 at the input of 0.05, and then you have sensor 5 connected to input of 0.06. So this multiple condition must be fulfilled before it can activate the differential U function. Okay, so another method is by using differential U in the call itself. Okay, so this is the example application of using the differential U and differential D, DIFU and DIFD at the coil itself. So how do we change the coil to be DIFU? We just click on the coil and press shift alias. It will be changed to DIFU, and for DIFD we need to press shift and percentage. Okay, so let's try and implement this one for DIFU and DIFD. Stop this one. Okay, for example, we take one coil over here which is connected to 0.04, sensor 3 for example, and then we want to connect it to a set button, a set function, and this will be connected to motor 100.04, which is motor 4. Then we connect the rung, and we want to change this to differential up. Okay, so we want to change this to differential up, so we can click on the coil and then click shift alias. It will be differential up. Then we add another rung with another coil for 0.05. This will be sensor 4 for example, and connect it to a reset. Reset instruction, again controlling the same motor, which is motor 4, and this will be connected, and we want to change this to DIFD. So for DIFD, we click on the coil and press shift percentage, so it will become DIFD. So we can try and run the system and see whether it works. Okay, so for sensor 3, which is connected to the set instruction, we will set the thing on. It will turn on the motor 4, and we want to change the state of sensor 4 to reset the system. So set it on first before we set it off. So it will reset the whole system. So that's how you implement DIFU and DIFD in the coil, and you can actually add multiple conditions in the same rung to be turned on at the same time to control the operation of motor 3. Alright, so let's have a look at example 2. I will skip this one and we will try to do example 3 because it is the same question, just that for example 2 we are using normally open type start and stop button, but for example 3 we are using normally open type start and normally close stop push button. So let's try and solve this example. Alright, so for the first one, we have assign the input and output with specific address. So let's try to put it smaller. Okay, make it smaller. So motor in figure 2 is started when the start push button is pressed. Okay, we have a start button and stop button. So this motor will be started once we press the start button, and it will continue to run once the button is released. Alright, so the motor will stop once the stop button is being pressed. While we turn on the motor, the light will turn on as well. Alright, so in simple word, the start button will turn on the motor and the light as well, and then once we release the start button, the motor and the light will remain on until we press the stop push button. So first thing first, we need to assign the input and output address. Okay, so example 3, assign the input address and output address accordingly. So the input, we have a start button, and the start button we can choose this one. We can make it as start 1. We can choose 0.06. This is normally open type, and then we have a stop 1. We can choose I equals to 0.09 for example. Okay, and this is a normally closed type. Whereas for the output, we have two outputs. The first one is motor. So for example, we are using motor forward. So the output address is 100.06. Okay, and we have another lamp, which is, for example, we are using green lamp, and the output address is, for example, 100.03. Okay, so that answers the first question, which is assigning the input and output with specific address. Then we would like to design the motion sequence diagram for the system. Okay, how is the motion sequence diagram? Okay, so we have the input and we have the output as well. Okay, from the input we are pressing the start button, which will trigger both the motor forward be on, and green lamp will be on as well. Okay, and then we would like to turn off the motor after we press the stop button. Okay, so this is NO type and this is NC type. So once we press the stop button, motor forward will be turned off and green lamp will be turned off as well. Okay. So the third question is draw the timing diagram for the system. So how do we draw the timing diagram? So let's move on to C. Okay, so it will depend on our input and output. So the first one we need to draw the timing diagram, TD. Okay, so the input that we have is start 1, and then we have another input which is stop 1. Two outputs which is motor forward and green lamp. Okay, so based on the timing diagram, we would like to press the start button. So when we press the start button, so start button is turned on. So for example, like this one, so it will be 0 over here and turn on momentarily, and then I would like to press the stop button right after the start button is being pressed. Okay. So it will be turned on here, the stop button, and turn off again here. So what happened to the motor? So the motor forward will turn on as long as the start button is pressed. Okay, it will be triggered once the start button is pressed, but it will turn off once the stop button is being pressed. So we take the window over here. So in between the trigger of start button and stop button, so the motor and lamp will turn on momentarily, turn on for a while before the stop button is being pressed, and it will remain off as long as the stop button is pressed. Alright, so over here it will be turned on again once we press the start button, and it will remain on until the stop button is being pressed. So the motor is on here, and same goes to the lamp. It will just follow the motor. So that would be the timing diagram for our operation. Suggest possible PLC programming ladder diagram for the system that complies with IEC standard. So for this one, let's draw a ladder diagram. So this will be D. Alright, so the basic ladder diagram by using output address, for example. So we want to use the first option for normal latching. Indirect method. We need to use indirect method, which is by using latching, because we want the motor to be turned on, to remain on once we release the start button. So the first option is by using output address. So we have the first rung, 24 volt. Okay, so start 1, which is at the address of 0.06, and then we would like to implement a series of, in series, okay, we like to implement a stop button. Because the hardware is normally closed, so we implement normally open stop button in the software. So this one is using the input of 0.09, which is connected to our motor. Okay, so this motor is set to be parallel with our lamp. Q 100.06 and then another Q 100.03. Okay, so this should be opposite of the hardware. Hardware is normally closed, so the stop button in software is normally open. So we would like to latch it with our motor. For the motor and lamp to remain on as long as we haven't pressed the stop button. So this will be motor forward Q 100.06. So this is the implementation of using output address. And then we have another solution by using internal relay, latching by using internal relay. So how do we implement this? We use the same concept. So we have the first rung. This is start button, and then connected in series with stop button, and connected to our internal relay. Okay, we can choose 5.00 for example. So this one is 0.06, 0.09. Okay, and in parallel with our internal relay 5.00. And then at the second rung, we would like to enable the output, which is our motor together with our green lamp. So motor forward Q 100.06, green lamp Q 100.03. So this will be our internal relay 5.00. Okay, so this is the implementation by using latching indirect method, and you can see that we are implementing opposite of the hardware. For the stop button, we implement opposite type of the hardware. Next one is we would like to modify the program using set and reset instruction. So I will continue that in the third part of the lecture.